In the assessment of where we've been and where we're going in today's lecture, I mentioned this concept of random error again and randomization and the role that it plays. And that's what we're going to spend a little time talking about here. Because once we move from single indicators to composite measures, we get into a whole set of theories called classical test theory, or there's modern test theory. There's a whole bunch of ways that we think about how we take these composite indicators and turn them into something useful. But we also have a whole bunch of error to deal with. And in classical test theory, there's a formula, a very simple formula, that we use to conceptually understand what we're going to do with all of the indicators to get to a single number. And for this formula is the score that we've observed, the score that we've got from all of our questions is comprised of two components. One, the true score, the actual amount of depression you have, your actual political beliefs, your actual health status, and random error. That error, that error can be systematic or random. And again, we're going to like random error. We'd rather have no error, but if we're going to have error, we want it to be random error. Systematic error is very bad. So there's two components, right? The actual score and error. Now, what is error in this concept, in this arena? Error could be a number of things. So years ago, I was teaching this very class at San Jose State in California, and it was a Friday night class, and it was right before a football game, and I was giving an exam, and right outside the window, literally right outside the window, where my students were taking an exam, was the band practicing for tomorrow's football game. So my students had to take an exam with a band playing music right outside their window, the boom, 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 boom tuba blasting at them as they're trying to answer questions on reliability or levels of measurement. And you can imagine that they performed less well than they would have if they would have had a quiet, peaceful environment in which to take the test. That band being outside is error. It induced error into my measurement of their understanding of the material we were covering. Sometimes the questions we use are poorly worded. Sometimes people don't understand them. Sometimes there's language barriers. There's an instrument for measuring depression called the POMS, and one of the things it asks is a variety of things. Are you feeling sad? Do you feel down? One of the questions is, do you feel blue? And I was working with somebody that was a Spaniard from Spain and was not a native English speaker, and so he didn't understand what blue meant. It's like the question, are you feeling fuchsia today? He just had no idea what blue meant. And so in answering that question, there's a little bit of error introduced by his lack of being a native English speaker, or the poor vetting of the question by the instrument developers, depending on your point of view. And so there's a whole host of things, from question wording to the environment in which the test is taken to a particular mood state. We all have days that are better days than other days, and if I ask you a set of questions, there's going to be some variability. Anybody that monitors their weight knows that there's a whole host of things that introduce error into the measurement of one's true weight. So all measurement contains some level of error, and this formula is an attempt to make that concrete so we can deal with it. So with regard to random errors, any factor that randomly affects the measurement of our variables across the sample, in other words, if everyone is equally affected by the error, then the random error will add variability to my data, but it doesn't change the mean of my data. It doesn't change how much depression I think a person or a group of people have. So random error makes it a little harder for me to see differences, but it doesn't affect what the true value is. And you can see that by this picture over here, which is a picture of a normal bell curve or a Gaussian curve. So one has random error, one has no error. You'll see the one that's skinnier has no error. The one that's wider has random error. So random error increases the spread of that distribution, the normal distribution. But you'll notice that the mean, which is right in the middle of those distributions, is exactly the same for both of those. So random error makes it a little harder to detect difference. spreads out my variability, increases the sample size necessary to detect difference between the control group and the experimental group or whatever it is that I'm doing, but it doesn't affect what the average score is, which is an important thing that we use to determine whether treatments are effective. Systematic error is bad because it shifts the mean of the distribution and doesn't just increase variability. It does increase variability, but it also shifts the mean of the distribution. And we often refer to this as bias. And you can see that in this picture right here, where we have a distribution with systematic error and a distribution without systematic error. So systematic error moves the distribution, random error spreads it out. But the thing we're going to be spending our time looking at are the average score of people that had cognitive behavioral therapy and the average score of people that got usual care on their depression score. So if the average score of the cognitive behavioral therapy group is lower than the average score of people that got the control treatment, then we know that cognitive behavioral therapy reduces depression relative to the control group. But if we have systematic bias, it's hard to know whether it's cognitive behavioral therapy that's inducing that difference or whether it's some form of systematic measurement error that's inducing that difference. Whereas random error just means that we have to have a little bit larger sample size to detect that difference. We've talked about how threats to internal validity induce bias in our ability to make causal inferences between treatment and control groups. We've talked about how a variety of different sampling biases can induce bias in our ability to generalize from our sample to a population. And now we're going to talk a little bit about sources of bias in measurement through, this is true of almost any questionnaire, but it's particularly true of scales or composite measures that we're talking about here. So the first form of bias is acquiescent bias, and that's where people just like to say yes. So you'll often ask people questions, and if they're not particularly interested in answering your questions, they'll just go, yeah, and not really be thinking about what their true answer is. Social desirability bias is a very similar one, where I'm going to tell you what I think is the socially desirable answer. If you ask people, are you racist? People are going to say no. Now, they might not like group X, or they might have prejudice or bias or bigotry that they hold dear to themselves, and they might recognize it, but they're not going to tell you that when you ask it because it's not socially desirable to admit to those things. So anything about drug use or sex, sexual behavior, or difficult social things like race or sexual orientation, all these kinds of questions that deal with sensitive topics for which there's a socially desirable answer, and then there might be some internal state that people have that differs from that socially desirable answer, are amenable to social desirability bias. There's cultural bias. If you look at questions related to the DSM, a lot of people don't think of their problems as psychological problems. They think of them as physical ailments. So if you ask somebody from China about their health status, their depression might manifest in something called neurasthenia, which is more of a physiological reaction, rather than depression, which is a more psychological reaction. So you might, in asking a bunch of depression questions that work well with people that are native to the United States, you might find those people are much more likely to answer those questions relative to somebody that's native to China, despite the fact that their underlying psychological distress on the depression continuum is actually the same. So there's all sorts of forms of cultural bias. Interviewers can also introduce bias. So if I'm asking a set of questions and I'm like, you really think this, right? And I can get people, I can induce people to answer a question in a particular way. So instead of saying, do you think President Obama is a good president, you could say, you don't really think President Obama is a good president, do you? So you can ask questions in a way that induce a certain set of bias, leveraging some of these other things like acquiescence bias or social desirability bias. So in developing questionnaires and asking questionnaires, in appraising questionnaires, how neutral the questionnaire is and how how it's able to hold back its own set of beliefs is an important element in getting unbiased data.